Okay, let's continue with organometallic compounds. Where we stopped at was we did basic introduction to organometallic compounds. Okay. Now we have to study some non-classical ligands, and then after that we do something called as synergic bonding. We write some specific examples. Uske baad we'll do colors, and that completes the chapter. I hope everyone has already written applications. Okay.
So yesterday is the second one which you given for homework. Can you discuss?
Okay. Please write down non-classical ligands. Non-classical ligands. Now, just like people, classical ligands have something called as denticity. Non-classical ligands have something called as hapticity. Hapticity is given by this symbol. इसको हम क्या बोलते हैं people? Eta. Please write down. Hapticity is the number of donor atoms, that are directly connected to the metal center. On the basis of hapticity, the ligands are classified as right on the first one. Monohaptic ligand. For example, copy the example, people. So only one donor atom connected to the metal. I repeat, only one donor atom connected to the metal. Next, write down. Dihaptic, yeah, this is also called as dihaptoligand, where eta will be 2. So we have 2 donor atoms attached. After dihepto we have triheptoligand, where you have 3 donor atoms. Keep copying the examples. After trihepto we have tetraheptoligand. Eta is 4. Followed by pentaheptoligand. And the last that we have is hexaheptoligand. Quickly copy this for me. Swarnika. Pause. Based on, please write down, based on the nature of metal carbon bond, based on the nature of metal carbon bond, based on the nature of metal carbon bond, OMCs are further classified as OMCs, organometallic compounds, are further classified as first, sigma bonded, second pi bonded. Let me write down the first one, sigma bonded. In sigma bonded OMCs, there exists a sigma bond between the metal and carbon. I repeat, sigma bond between the metal and carbon. Next point. Mostly observed between non-transition and metalloid elements. Between non-transition and metalloid elements. For example, copy the examples, people. For example, quickly copy the examples. Yes. Next item, pi bonded. Pi bonded. Sonika, can you pause for this one? I know. So that was sigma bonded. Next, please write down pi bonded. Metal is bonded. Metal is bonded. Metal is bonded to the pi electron cloud of the ligand. Metal is bonded to the pi electron cloud of the ligand. Next point. Pi bonding here does not indicate the nature of the bond. Pi bonding here does not indicate the nature of the bond, since the overlap is usually both axial as well as lateral. Since the overlap is both axial as well as lateral. Now copy the example of Z salt, where we see that the central metal is bonded to the pi bond of the ligand. Eta, it's a dihepto ligand. That is what. So, though they might not ask about hepticity, but we have Z salt. Now, what does the eta 2 here represent? That's a dihepto ligand. Isliye we need to know about different hepticity. Now these are usually formed by transition metals. वो भी लिख देना. These are usually formed by transition metals. Please add that point. So the pi bonded metal carbonyl bonds are usually formed by transition metals. एक दो और एग्जाम्पल लिखते हैं उसका. Okay, so what we have here is a compound called as ferrocene. So ferrocene may we have a pentaheptoligand, which is cyclopentadienyl. We've also made that here, cyclopentadienyl. ये है वो. ठीक है. Now look at the structure of this. So we have the cyclopentadienyl. Then we have Fe. The charge on Fe over here is +2. This is -1. This is +2. And we have one more. If we try and calculate the EAN or effective atomic number, so for Fe, the atomic number is 26. Fe +2 will become 24. Getting that?
Yeah.
And क्या पहुंचना चाहिए usually when we study this? It has to reach coordination number 6. So which means how many lone pairs do I need from the pentadienyl? 6. Which I can see that यहाँ पे 2 over here and 2 over here. So 6 from here. Similarly 6 from here. So what is the EAN? 36. Did you will get that? Copy the example. Ferrocene. And there's one more. I'm so sorry. Pause करो उसको. Dibenzene chromium. Just a second. यहाँ पे इसके चाहिए तो मैं ऐसे बना सकता है. Same thing over here. 24, 6 and 6. So the effective atomic number comes as 36. These two compounds together, they are also known as sandwich organometallic compounds. Jaldi copy this for me. The next topic that we have, people, is called as synergic bonding. Now please understand, थोड़ा सा अलग है ये synergic bonding. Now this is our central metal atom and this is carbonyl. ठीक है? Before forming the bond, what's the bond order of CO that we see here? Bond order is 3. Now what happens? Central metal atom donates electrons to the ligand donates electrons to the central metal atom. Yes or no, people?
Yes.
So this is the empty d orbital of the metal.
Yes.
So the overlap here takes place between the empty d orbital of the metal and the pi 2p orbital of CO. Do you people remember this pi 2p? कहाँ पढ़ा था हमने ये? Bonding molecular orbital, and this results in the formation of what, people? Sigma bond. ठीक है? Coordinate bond बनता है. But now what happens here simultaneously is there are electrons present in the d orbital of the metal, and the metal now gives electrons to the ligand. What's happening here is the electrons which are present in the d orbital of the metal, and an overlap is taking place between the empty anti-bonding molecular orbital of the ligand. This results in the formation of कौन सा bond, people? Pi bond. This is known as synergic bonding. Understand this. Ligand is giving electrons to the metal, forming a sigma bond, but at the same time, even the metal is giving electrons to the and forming pi bond. The sigma bond strengthens the pi bond, and the pi bond strengthens the synergy. Things happening simultaneously. Did you people get that? Yes. The first overlap is between the pi 2p orbital of the ligand and the empty d orbital of the central metal. The second overlap takes place between the filled d orbital of the metal and the empty pi star 2p orbital of the carbonyl CO of the ligand here. Getting that? So CO is donating electrons, forming which bond?
Sigma.
Accepting electrons from. Hence CO is also called as sigma donor, pi acceptor. Did you people get that? Yes or no? वापस से. Before bonding, it was like this. आपका metal था. This was CO. Then what happened is CO donated electrons to the forming which bond? But at the same time metal ने भी donate किया and कौन सा bond form किया? So the initial bond order which was between the carbon and oxygen, now the bond order between C and O becomes 2. Did you get that? Yes or no? Now, stronger the bond between metal and carbon, weaker the bond between carbon and oxygen. Or weaker the bond between metal and stronger the bond between carbon and oxygen. थोड़ा सा अलग. As the bond order between M and C increases, as MC bond order increases, we'll do some questions इसके ऊपर. Bond order increases, bond strength increases, bond length. Did you get that? But as MC bond order will increase, CO bond order is going to, the bond strength is going to, and the bond length is going to. Did you people get that? Yes or no? ठीक है, थोड़ा सिंप्लीफाइड डायग्राम अगर चाहिए तो ये आपका मेटल था, दिस इज योर carbonyl. Carbonyl is donating electrons to the metal, forming what bond? Then metal is donating electrons to the ligand, forming. Did you people get that?
Yes.
Somewhat similar to back bonding that we did in chemical bonding, if you remember. हमने बैक बॉन्डिंग फ्रंट बॉन्डिंग का कॉन्सेप्ट किया था केमिकल बॉन्डिंग में. इट्स समवॉट सिमिलर टू दैट. डिड यू गेट दैट? पहले थ्योरी लिख लेते हैं. राइट ऑन. Synergic bonding, yes. Synergic bonding, bracket में you can write down bonding in metal carbonyls. Bonding in metal carbonyls. The metal carbon bond, please write down. The metal carbon bond in metal carbonyls. The metal carbon bond in metal carbonyls have both sigma and pi character. Have both sigma and pi character. Next point. The first overlap takes place between the filled bonding. The first overlap takes place between the filled bonding pi 2p orbital of CO, with the empty d orbital of the metal. And a sigma bond is formed. The second overlap takes place. The second overlap takes place between the filled d orbital of the metal. The second overlap takes place between the filled d orbital of the metal and between the filled d orbital of the metal and empty anti-bonding pi star 2p orbital of CO. Empty anti-bonding pi star 2p orbital of CO. Resulting in an additional pi bond between metal and CO. Resulting in an additional pi bond between metal and CO. This effect of sigma bond formation strengthens the pi bond and vice versa. This is synergic bonding. Synergy means working towards the same goal. We are all working towards the same goal. It's only me running. Record order. Synergic bonding. Next point. Synergic bonding are of two types. First, pi donor, pi acceptor, and sigma donor and pi acceptor. दोनों पाई एक. First, pi donor, pi acceptor. Second, sigma donor, pi acceptor. Right on. Examples of sigma donor and pi acceptor ligands. First example तो अभी हमने लिख दिया था, which was CO. No, just remember these examples for sigma donor and pi acceptor and quickly draw the diagram. Okay. Now, look at the first question, people. Arrange in decreasing order of मेटल एंड कार्बन बॉन्ड स्ट्रेंथ. ठीक है, इसका हिंट कैसे पीपल? ट्राई टू अंडरस्टैंड द हिंट. क्वेश्चन फिर एकदम इजी हो जाते हैं. ग्रेटर द इलेक्ट्रॉन डेंसिटी ऑन द मेटल, I repeat, greater the electron density on the metal. So when the metal is donating electron to the ligand MC, so what will happen? The MC bond order will increase, and if the MC bond order increases, its bond strength is going to, and its bond length is going to decrease. Getting that? And same ही हमने जो point लिखा था, if the MC bond order is increasing, it's obvious that the CO bond order will decrease. Similarly, greater the density, na, so lower the density, all these parameters will become ulta. But एक ही point याद रखेंगे, that is more than now. Now let's start with the first one. Arrange the following in decreasing order of bond strength. अब क्या करते people उसमें? If you look at the first trend, FeP, what is the charge on Fe over here? +1. Vanadium -1, and chromium is. So if you look at the three of them, the one with greatest electron density will be vanadium, followed by chromium, and FeP तो क्या charge है people? तो यहाँ पे trend क्या आ जाएगा? B, then C, then A. Similarly over here, CO is -1, nickel is 0, Fe is, so C, A, and then B. Greater the electron density, greater will be the MC bond strength. Greater the electron density, Fe2 minus will have the greatest electron density. Getting that? अब यहाँ पे people उल्टा करना है. If you are looking for highest CO bond order, which means we are looking for lowest MC bond order. Now when you are looking for the lowest MC bond order, what that means is you have to look for that metal with the lesser the charge or lesser electron density. I'm sorry, not lesser electron density, which is this, because only Mn over here is rest all -1, -2, and nickel is 0. Did you people get that? However, look at the last one, थोड़ा सा अलग है. If you look at the first compound here, see, this is chromium, and you have CO, and यहाँ पे क्या people? P, F3, P, and P, F3. We know that what is the nature of fluorine? It shows negative inductive effect, which means it will pull electrons towards, and it decreases the electron density on chromium. Did you get that? So due to -I of fluorine, what happens people to the electron density of chromium? The electron density of chromium, I repeat, the electron density on chromium decreases, and we know that if the electron density decreases, what will happen to the MC bond strength? Bond order will decrease, the bond strength will decrease, and what will happen to the CO? CO bond order is going to increase, bond strength is going to increase, and bond length is going to decrease. Did you get that? On the other hand, if I look at this example, triethyl phosphine, so chromium, this remains, this part is the same, यहाँ पे what do we have? And we know that alkyl groups show what property? Plus I. So since it is plus I of ethyl, what will happen over here? The electron density on chromium increases. So I want you to write that. I repeat, the electron density on chromium increases due to the plus I effect of ethyl. Did you people get that? Yes or no? Okay. Copy this. We stop for the day. However, we still need one more lecture. उसमें से part lecture what we'll do is we'll do the topic which are left, and part lecture में we'll go through all the questions of booklet जो भी doubt रहेगा. So whenever we meet next class, I think that is on Monday, we'll be doing the last part of the chapter which is left, and I want you to complete the booklet and come. We'll discuss booklet questions. ठीक है? Thank you.